Hi folks, today's video lesson is going to be about using properties of exponents. So you should have a good idea of how to use the properties at this point, but this is a nice little review to help out with some of the finer details. We're going to start from the beginning here on talking about the product of powers rule and the quotient of powers rule, and then we'll look at some of the other properties and look at some of the pitfalls that they come across with some of these examples, and then we'll end with a real-life problem here. So let's look at some of the basic principles here. When we are multiplying with the same base, we have a base of 2 times a base of 2. What this first term is saying is that we have the base of 2 7 times. 2 times 7 times 7 times 7, excuse me, 2 times 2 times 2 times 2 times 2, 7 times, right? 4, 5, 6, 7. Times, from the next factor, the factor of 2 3 times. For a grand total of, and you can look at these and add them up, 2 to the 10th. But that's the long way, right? The short way is to look up here and say, okay, again, same base, we can just add our exponents, right? So we can say this is 2 to the 7 plus 3, or 2 to the 10th. Similarly with division, this again is saying the factor of 2 7 times, or the factor of 2 3 times. And then because it's all multiplying the numerator, all multiplying the denominator, I can actually cancel all these pairs of 2 that I have in the numerator and denominator. And we're left with 4 factors of 2 up top. So we can say that this is 2 to the 4th. And again, that's the long way. Do you know what the short way is? Okay, the short way is we can subtract with our exponents. Sorry, I'm running too loud. Obviously, it's in my brain there. So we can say this is 2 to the 7 minus 3, or in other words, 2 to the 4. Okay, so we're going to look at one more property, and these first 3 are really going to be the core of what we do, and really in the rest of these problems here. So what's going on in this next situation here is we have 3 factors. We have the factor of 2, the factor of a to the 4th, and the factor of b, and they're all being cubed. They're all inside this parentheses being cubed. So when it's multiplication on the inside, what we can do is we can distribute that power of 3 to all these terms here. And that's only across multiplication or division. This doesn't work over addition or subtraction. So I can rewrite this as 2 to the 3rd, a to the 4th 3 times, right? And b to the 1st 3 times. If I can simplify this, I know 2 to the 3rd is 8. A to the 4th 3 times, well, I can do a to the 4th times a to the 4th times a to the 4th, and I know that that's really just adding those exponents. So I can write this as a to the 12th. And hopefully you can see the shortcut there with the 4 and the 3 to get the 12. And likewise with the b, I can say that this is b to the 3rd. Similarly, I can distribute the exponent across division as well. So I can say that this is 3 to the 2 over 3 to 3, excuse me, over 4 to the 2, or in other words, 9 over 16. Okay, so let's move on to some more complicated problems. We're going to do these one at a time. If you notice, these are all very similar. So we're going to start with this one here on the left, and then we'll just add a few more terms to it and look at how it gets a little more complicated. So in this first problem over here, when I look at this, I notice that okay, I have a 5 out front, I have an x, I have one term with a y, one term with a z. The way I look at this is really, this is 3 distinct problems. Excuse me, 4 distinct problems. I'm dealing with the coefficient first, I'm dealing with the 5, then I'm going to deal with my x's, then I'll deal with my y's, and then I'll deal with my z's. And this first one's pretty simple. I only have one term of each. So I'm going to distribute this 2 to all the factors on the inside. Clean this up a little bit for us here as we go along here. So this is going to be 5 squared times x squared times y cubed squared, which is y to the 6th. So I'm going to multiply those exponents. And in the denominator, I'm going to have z to the -5 times 2, or -10. And I'm going to clean this up a little bit. My 5 squared is 25. X squared, there's nothing I can really do with that. I'm just going to leave that as x squared. And same with the y to the 6th. I'm going to leave it just the way it is. This z to the -10, though, I want to simplify that by changing to a positive exponent. So the way to change it to a positive exponent is that I'm going to cross the line. I'm going to bring it up top, and I'm going to change the sign. I'm going to change the sign of -10 to +10. And that's going to simplify my expression as much as I can. Okay, on to the second one on the list. Notice how most of the terms are the same. In fact, all the terms are the same, except that I've added this factor of 10 in the denominator. So I really know what my answer is going to look like. I'm going to have x squared, y to the 6th, z to the 10th. Those variables aren't going to change. That coefficient obviously is going to change a little bit. So here we go. My suggestion is before we do this squaring, I'm going to simplify the 5/10. And I'm going to make my life a lot easier. So the 5/10 I can cancel a little bit there, and I can say that this is 5 goes into 10 twice. And I can rewrite this as x y cubed over 2 z to the -5. All of that is being raised to the 2. So since I know how the variables turn out, I'm really just going to concentrate on my coefficient here. And I have this 2 in the denominator that's being squared. So I know I'm going to end up with a 2 squared or 4 in the denominator. And the rest is all going to be the same from this first problem here. I'm going to have x squared, y to the 6th, z to the 10th. Okay, on to the last problem here. These are different enough that I'm not going to look back to the first problem or the second problem and use that same answer. I'm just going to go through this bit by bit. And again, what I said before with the first problem is these are really 4 distinct problems. I have my coefficients, I have my x's, I have my y's, I have my z's. So I'm going to treat those as really separate things as I go along here. The key with this is to do the simplifying before you do the squaring. Don't square, or you can square all the terms first if you like, but you might find it a little bit easier to do all the simplifying and then go about with the squaring part here. So here we go. First thing I'm going to do is I'm going to simplify the 5 and the 10. So I know I can divide 5 into 10 twice, so I'm going to write that as 1/2. And now I'm going to move on to my x's. I have an x to the first up top. I have an x to the -3 down below. So the first thing I'm going to do is I'm going to move the smaller exponent, which is the -3, to the larger exponent. So I'm going to move the x to the -3 up top. When I cross the line, I'm going to change the sign. So I'm going to have an x to the 1 and an x to the +3 up top for a total of x to the +4. And now we're going to move on to the y's. Well, it's kind of nice because the y's only have one term, right? So this is going to stay as y to the +3 on top. And then I'm going to move on to the z's. Notice how I have a z to the -5 down below, z to the +1 up top. So I'm going to move that z to the -5 up top, cross the line, change the sign. So that's going to be a z to the 1 up top and a z to the 5. I'm going to add those exponents. I'm going to get a z to the 6th. And this is all being squared. And since I've done all really the hard work here of getting rid of the negative exponents, combining some like terms, the squaring part now is relatively easily. I'm just going to double all my exponents. So I'm going to have x to the 8th up top, y to the 6th up top, z to the 12th also up top. And now I'm also squaring the 2, so I'm going to have 2 squared, or 4, in that denominator. And that is that original expression now simplified. Okay, so here's a practice problem for you. Notice how it's awfully similar to what we just did, except the parentheses are a little bit different. So I'm going to let you folks do this one on your own. You might want to pause the video in about 5 seconds here, and I'm going to reveal the answer. So go ahead and pause it and see if you get the same answer that I have here. So that's what I get. Check your solution, and if you get something different, see me in class, and we can go over this. Okay, last problem here. We're going to write an expression for the area of that circle in terms of x. So what do we know here? Well, we know the area of the circle is pi r squared, and the radius I'm giving you is x over 2. So what I'm going to do in place of r is put x over 2. And then I'm going to simplify this. So I have the area equals pi, and now I need to square this whole base here. So remember how we did this before with the fractions. You just treat the numerator and denominator separately. So I'm going to square the x, and I'm going to square the 2. And that's really all we can do with this. If you want, you could rewrite this and say, okay, area equals pi x squared all over 4. If you want to write it in one fraction, that would be fine. But anyways, that wraps up our tutorial on exponents. I hope you enjoyed this. I hope you found this beneficial, and I'll see you folks later on.